This is an example to illustrate sampling distribution and central limit theorem. The problem is this. Your company has bought a laser cutter that automatically cuts steel rods. The seller of the laser cutter claims that the cutter cuts rods with a mean length of 96 inches and a standard deviation of 0.5 inches. Assume that the lengths are normally distributed. You randomly select 40 rods and find that the mean length is 96.25 inches. Assuming that the seller claims is true, what is the probability that the mean of the sample is 96.25 inches or more? Before we solve this problem, let's recall the central limit theorem. It says that if x bar is a mean of random sample of size n from an infinite population with mean mu and standard deviation of sigma, and the sample size n is large enough, then z equal to x bar minus mu over sigma by square root n has approximately the standard normal distribution. And when is the sample size large enough to apply central limit theorem? In practice, as long as one of condition is true, in particular, if the population distribution is approximately normal, then we can apply the central limit theorem. So let's go back to our problems. We are given that assuming that the seller claim is true. That means the seller claim that the lengths are normally distributed. That means the seller claim that mu is 96 inches and standard deviation 0.5. And we are assuming that the lengths are normally distributed. That's why the condition is satisfied. We can apply the central limit theorem, right? This is a condition for central limit theorem to apply. And we find that when n is 40, which is large enough, we have select a sample size of 40. So n is equal to 40, which is large enough. The mean length is 96.25 inches. Part A, the probability of mean of sample is 96.25 inches or more. The mean of the sample means x bar is 96.25 or more, means x bar greater than or equal to 96.25. Now, according to central limit theorem, z equal to x bar minus mu over sigma over square root n is approximately standard normal. That means you can use the standard normal table to find the probability. So this is the same as probability of z greater than or equal to 96.25 minus mu is 96 over sigma is 0.5 divided by square root n, where n is equal to 40. This is the same as the probability of z greater than or equal to 3.16. And then we find the probability from the table. What we want is you have a standard normal, center is 0, and you want to find the area greater than 3.16. The area here. Now from the table, the area from 0 to 3.16, we find out that this is equal to, check the table now, 3.16. So you'll find that 3.0123456.4992. The area we find out from 0 to 3.16 is 0.4992. That means that this blue area here is 0.4992. So the area of the yellow tail is 0.5 minus 0.4992. This answers the part 1. Next, we come to part B. Using your answer from part A, what do you think the seller claimed? So, part 2 now. Using the answer in part A, what do you think of the seller claims? First, the probability of x bar greater than or equal to 96.25 is very small now, 0.008. So from here, I know that the claim by the seller is not correct. This is because it is very rare to have 40 rocks with mean greater than or equal to 96.25 if the claim of mu equal to 96 were true. And now I have a sample of 40 and the mean is more than 96.25. Let's look at part C now. Will it be unusual to have one rock with a length of 96.25 inches? What is the probability of x greater than 96.25? Z equal to x minus mu over sigma, which is equal to x minus 96 x sigma 0.5. It's normally distributed, so we can put this probability of z greater than or equal to 96.25 minus 96 over 0.5, and this is the probability of z greater than or equal to 0.5, and the probability of z greater than or equal to 0.5 you can find standard normal 0.5, probability of z greater than or equal to 0.5. Based on the table, the area from 0 to 0.5 we find on the table area from 0 to 0.5 is equal to 0.1915. Therefore, this area is 0.1915. So the probability of z greater than 0.5 is 0.5 minus 0.1915 is equal to 0.3085. And this is not rare, so it's quite common for a rock to have a length of greater than 96.25. However, it is rare for the mean of 40 rocks greater than or equal to 96.25. And that is the end of this recording.